Okay, this is an example, example number 4. We are in parabolic motion or projectile motion, and as you know, in the projectile motion, the only acceleration that we have is gravity, which is in the y direction. So if we put our coordinate system right here in the initial position, right, is x and y, we will have that the acceleration in x along all the trajectory is equals to 0, and the acceleration in y, which will be equals to negative gravity. Be aware that if we are talking about units in British system, which is feet and over second as given the velocity, our gravity is 32.2 feet over second square. So the solution of this problem is very similar as the other problems in projectile motion. We always start that the velocity is the derivative of the position respect to time, and the acceleration is the derivative of velocity respect to time. So in x direction, that we do not have any acceleration, right? We integrate the acceleration and we give that the final velocity in x will be equals to the initial velocity in y, and if we integrate that expression respect to time, we get that the final position will be equals to the initial position plus the velocity in time. And in the y direction, we have that the velocity in y will be equals to the initial velocity in y minus, right, the acceleration times time, because we integrated respect to time, and the final position in y, right, is equals to the initial position in y. So I integrate this expression. So those expressions you know it by heart, but I just want to make sure that you know where they come from. What is this problem as given? So, and what do we have to find? So they are giving us the initial velocity and the direction. So we have the initial velocity, and since we have the direction, we have these two components. We are given the gravity, and we are missing the time, and we are being asked to find the final position, which is D. So we need to find the final position, which is in the x direction and in a y direction, because it's in an inclined plane. Since we put our coordinate system in the initial position, we know that this is 0. So we can use these two expressions. So let's call this equation 1 and this equation 2, and we will have a problem with two unknowns, two equations with two unknowns, because we will have the initial velocity is known, so we will have time and final position as the unknowns. So for this expression right here, we see that we have distance, and the angle between the distance and the horizontal is parallel to that, so this is 10. So we will have that this is distance cosine of 10 degrees is equals to initial velocity. We are also given the angle. Be careful, because we are given the angle between the initial velocity and the inclined plane. So we have to have it between the initial velocity and x angle. So we have to find that angle, which is 45 plus 10 degrees. So that will be equals to 80 cosine of 55 times the time. This is my first equation, right? And the second equation, I will write it right here, will be d sine of 10 degrees equals to that 0. So I will have velocity of 80 sine of 55 degrees times minus 32.2 over 2 times square. So as I said, we have two equations with two unknowns, which are time and distance. There are many ways to solve that. I can solve for D here and leave time and plug in here, or vice versa. So solving system of equations I get that distance is equals to 66 feet. So since we don't have to find the time because we are not asked to find the time, I will just solve for t here. So if you want to solve it, so t will be equals to distance cosine of 10 over 80 cosine of 55, and that into 2 in the two equations, and then you solve for t. Okay, this is the solution for this problem.